The objective of this lesson is to represent multiplication using an array and draw the representation using the box, line, dot method. As with other mathematics algorithms, much time is necessary to develop the math thinking conceptually before introducing the steps of the algorithm. Introducing array models and open arrays, such as those in this lesson and the following lesson, helps students understand the steps of the algorithm taught in 5th grade. For today's lesson, we will use base 10 blocks and arrays to help us with multiplication. Here's the vocabulary needed for this lesson. An array is an arrangement of objects in equal rows. A closed array is a rectangle used to represent the array with rows and columns clearly marked. An open array is a blank rectangle used to represent an area model with the two factors written on the side and top of the rectangle. Let's start with 3 times 5 and build a 3 times 5 array using the ones cubes. When I see the multiplication symbol, I think 3 groups of 5, or in this case, 3 rows of 5, which equals a total of 15 cubes. To draw the array, I can use dots to represent the ones cubes. Can you change this array to represent 3 times 9? Instead of 3 rows of 5, I'll make 3 rows of 9, which equals 27 total cubes. To draw this model, I'll add 4 extra cubes to each row to make rows of 9 for a total of 27 cubes. What about 3 times 11? To make it easier, could I use a rod or a 10 stick for 11 instead of counting out all the ones cubes? To represent the problem, I have 3 rows with 11 in each row. To find the product, I count 10, 20, 30, 1, 2, 3, or 33. To represent this with a drawing, I use dots for my ones cubes and a line for the 10 sticks. Let's try a larger problem, 5 times 23. To build this array, we need 5 rows with 23 in each row. To count my answer, I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, or 10 tens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1. So 5 times 23 equals 115. To draw the array for this problem would be 5 dots, 4 rows, with 2 rods for tens and 3 ones per row. Let's try one last problem, 4 times 31. To build this array, we need 4 rows of 31. To count the answer, we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120, and 4 ones, so 4 times 31 equals 124. To draw the array, we draw 4 ones with 3 rods or tens and 1 one per row. Having your child use the base 10 blocks or draw the model using the box, stick, dot method will be good concrete models to deepen student understanding of multiplication and lead to better understanding of the steps of the algorithm when presented in 5th grade. In this lesson, we learned how to represent multiplication using an array. We met this objective by first building models with base 10 blocks and then drawing a model of this representation.